And welcome everybody to the Daily Space Weather. Smasho here coming at you from the Smash News Network, least busted name in news. As we bring you the most detailed imagery of the sun you'll find anywhere. The most comprehensive space weather. We'll be doing cosmic rays today and talking about different wavelengths. So we'll be showing composite imagery here. This is 193 plus 1700 angstroms. Those wavelengths are good at showing things like the extended corona, filaments, coronal holes, and sunspots for the 1700 portion. We'll also show you the last 24 hours in 304 plus 131 angstroms. That's ionized helium plus iron. 304 angstroms is great at showing filaments. Also active regions like sunspots and their activity. 131 is great at showing solar flares. And we did have one significant solar flare from a region not yet in view up here behind the northeast limb. So we are expecting some additional sunspots to rise soon. Likelihood of large solar flares remains very high here. While we're at it, here is the 171 plus 335 angstroms wavelengths. This is great at showing the magnetic looping of the lower corona for 171 angstroms. 335 angstroms is great at showing active regions and adds some depth. That is the last 24 hours. We have had a small increase in solar activity since yesterday. So if you enjoy the content, press like, subscribe, and share. If you want to support the channel, if you like the videos and you prefer to see them continue to exist, remain publicly visible and free for all to view, visit our links, help us out in whatever way you're able and willing to do so, as big tech organizations seem to be trying to suppress the content as opposed to trying to promote it. It's 2022 after all, and facts are very controversial since the year 2020, when all of society's institutions were undermined systematically. Anyway, join at the gold or silver Smash Team level to help us continue to make sure that this content continues to exist. Thanks to our Smash Team members. Credit crawl rolling. It's coming back before the end of the year. Once again, thanks to the Smash Team. SmashOmash.com/Smash Team is the official subscription services site of the Smash News Network, least busted name in news. You can also find our merch link below the video as well as on the homepage. If you click that link, you'll find our products in order of best selling. Current bestseller is Do Not Pole Vault the Caldera. Some words of wisdom for you there. So whether you're looking for Universum Liberate, Fauci fraudster face of evil bath mat perhaps, or maybe forgive, remember, and hold accountable, today's featured product is, well, it is associated with cosmology after all. And today's featured product, wait for it, is the galactic current sheet. Because some people out there on YouTube are spouting complete and utter nonsense about cosmology. Look at how scary and spooky it looks. Oh, noes. The galaxy, it's very big and scary. Oh, noes. Yeah, the galactic current sheet. That is today's featured product. The throw blanket, by the way, is extremely plush. Here's a quick rundown of what products can be found. All kinds of different products there featuring the galactic current sheet. Maybe put it up as a shower curtain so that you can shower on the right side of the galactic current sheet. Retire to your bunker in style and tell all your bunker mates incessantly that the galaxy is what caused civilization to collapse, not terrible decisions by bureaucrats. When in doubt, blame the galaxy because it's big and big things are scary, as we know. Let's take a look at volcanoes. Big things are scary, folks. Don't be spooked of anything small. Make sure you find the biggest thing. Ooh, the galaxy. The only thing scarier than that is the universe. Let's check out volcanoes. There's a great diagram of Kerinci there on Sumatra. If you want to read about that, there's some activity going on there. Shivaluch producing a 15,000-foot ash plume over Kamchatka. That's a flight level 150. So Kerinci has an increasing trend of activity and a continuous rise of seismic activity in the past 2 days. So perhaps as the alert status remains at level 2, there is a likelihood of significant eruptions there at Carinci. Popocatépetl exploding in central Mexico, flight level 200. Fuego in Guatemala exploding, flight level 150. Sangay in Ecuador exploding, flight level 150, 15,000 foot ash plume. Sangay flight level 210 in Ecuador, Revenador flight level 150, and Sabancaya continuous ash emissions. Don't pole vault the caldera. Do visit our links. Next, looking at seismicity, there's your 90-day bar graph to put things in perspective. And here is the last 24. No major quakes, some in the 5 magnitude range, however, like this 5.2 at the Philippines. Most of the quakes have been north of Australia here. We'll just run up the list. And if we miss anything, let us know in the comments. We don't want to spend too much time on earthquakes, but we like to have things from a complete global and space weather perspective. So here is there's a 5.3 at Indonesia. There was a 5.0 at Indonesia. And another 5.0 south of there. Also a 5.3 at Chile. And a 5.4 at Tonga. Those are the largest quakes of the past 24 hours. And let's get back to the realm of space. So now we're actually showing 4,500 angstroms plus 335. We don't typically show the 4,500 angstroms because it's very strange. And frankly, I don't know that much about it. But it's always interesting to check out all the wavelengths. Let's switch to something a little bit more coherent here. That's 4,500 plus 335 angstroms. And let's switch to... there's 193 plus 1,700. And the radial flux has come up to 163 solar flux units. So an increase in the radial flux here. Expecting that to be basically level, maybe even come up a little bit as we have a highly active region rising in the northeast. So the radial flux now up here at 163 solar flux units. For you new viewers, the 10.7 centimeter radial flux comes from the upper chromosphere and lower corona, about where my pointer is located. And it is the most proportional data that we have to sunspot number in terms of solar activity. So when we see high sunspot numbers, we see high radial flux, and so on. Space Weather Enthusiast dashboard not forecasting any additional geomagnetic unrest conditions, although I wouldn't be surprised to see some here as we're seeing a shifting magnetic field into the higher magnetic field intensity range here. We've been seeing an increase in the BT, and the BZ has just swung into negative territory. So if it stays there with a solid signal, we will see geomagnetic storm conditions. At the moment, it's somewhat geomagnetically calm here, approaching geomagnetic unrest. We do have an elevated coronal hole high-speed stream. So we did see geomagnetic storm conditions for a brief period of time. That came back down to KP 3.67. which is where we're currently located. Let's take a look at Earth's magnetic moment from space. This is the last 4 hours of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework. The units depicted in this imagery are nanopascals, which is magnetohydrodynamic pressure. So that's what's been going on the past 4 hours as we've just recently gone past the December solstice as the sun gets higher in the sky in the northern hemisphere. Here are our ground magnetic perturbations. The units depicted here are nanotesla magnetic flux density. That is Earth's magnetic moment from the ground for the past 4 hours. We show it from space, we show it from the ground, and that's what's been going on. Earth's magnetic field. It's apparently still there because, well, there are facts. Next, moving to the real-time solar wind. Like I said, the field has been increasing. So we've seen the field go from 7 nanotesla up to 12 nanotesla. At the moment, it is 12 nanotesla for the BT. BZ is -9. If it stayed there, we would go into geomagnetic storm conditions, certainly, with this level of solar wind speed, which is about 520 kilometers per second. Make that 540 kilometers per second. So we are seeing the solar wind speed increasing here. Solar wind density only about 4 protons per cubic centimeter. It's a high-speed coronal hole wind stream. Let us know in the comments where you think the top of that will be. I think it'll only get up to about 550 kilometers per second. I think we're basically at the top at the moment. And let's look at some magnetic data. There are your GOES magnetometers. And some very low readings there showing up. Keep in mind that is midnight local time for the satellites. Midnight local time denoted by these N's. That's noon local time where the N's are located. N as in Nancy, M as in Mary, and you get the idea. Next, top view ecliptic plane field plot. We have seen a South Pole current sheet arrive here at Earth. And what's interesting about this is that we see a North Pole current sheet popping up, so there may be some sunspots in the southern hemisphere out beyond stereo A. So that's sort of a forecast here just based on this rough data. The data in this imagery is gathered from 51 ground-based magnetometers as well as magnetometers on stereo A at Lagrange 5 and stereo B at Lagrange 4. Here's our line of sight field plot. Solar B field depicted in blue, north solar polar field in green, south solar polar field in red. And before we get to coronal holes, we are going to move to cosmic rays. So here's our cosmic ray update. We haven't done one in, I think, over a week. So we're going to start as far south as we can get. This is Antarctica. And DOMB Antarctica's cosmic ray monitor is actually flat over the past 30 days, following a recent downtick. But over a 30-day span, DOMB Antarctica is a flat level of cosmic ray flux. DOMB Antarctica is a small downtick, a similar shaped graph. And let's go way up north to the land of Finland, to Oulu. There's Oulu, significant downtick at Oulu over the past 30 days. And let's go much farther south to Mexico City. So Mexico City's cosmic ray observatory there showing a tiny downtick in cosmic ray flux over the past 30 days. And let's go back up north to Greece. Greece showing a small downtick over the past 30 days. So cosmic ray flux levels here almost flat despite a major uptick in solar activity, at least on a 30-day basis. And at last we'll show Apatity in Barentsburg. There's Apatity, significant downtick at Apatity neutron monitor. And at Barentsburg, a slightly less significant downtick. So a slight downtick, nearly flat levels in cosmic ray flux on a global scale. That's your cosmic ray update. And let's move to, promotions. Yes, our latest affiliate / sponsor is Hemp Lucid. You can find links below the video as well as on the homepage. You'll save 40% at the moment. New year, new you. Do yourself a favor and save a bunch of cash by using our link. You can also use the promo code SMASHOMASH10 on checkout to save some cash. Shop by solution. The most popular products are the water-soluble CBD tinctures. So check those out. All kinds of other solutions available there as well. More product reviews coming as well. Take a moment to press like and subscribe if you enjoy the content. Check our playlists for content not related to space weather or meteorology. Although cosmology, I guess, is kind of related. There are also videos about driving, riding, and pro tips, terms defined, the diamond anvil too hard to smash. Smashomash.org presents the sun and lots more. Press like, press subscribe, press share, tell your friends and foes, leave a comment, etc. Thanks to everybody who has tolerated the pathetic censorship on big tech platforms over the past 6 years. You can also do yourself a favor by improving your health by becoming a member of the American Better Health Organization, DBA SureMed. It's not insurance, although I am a licensed Medicare insurance agent in 28 states. If you're looking for your insurance options, drop me a line. And if you're looking to improve your health with an American Better Health Organization membership, sign up via my link. I'll be your agent of record. All kinds of features there like the teledoc service. Make it worth it by itself. Also discounts on MRI, CT scans, labs, pharmacy products, vitamins, durable medical equipment, and lots more. And let's get to coronal holes as we return to space weather. There's your coronal hole scenario. We've got South Pole-oriented coronal holes rotating in here in the northeast. And also South Pole-oriented coronal holes hanging out around the South Solar Polar region. We've got a long way to go to reach solar max, as the North Solar Polar Field has to make it to the south and vice versa. At the moment, they're nowhere near that process. This is a South Pole-oriented coronal hole. This is a North Pole-oriented coronal hole. That's 211 angstroms. That wavelength is great at showing the extended corona filaments and coronal holes. Next, we'll move to sunspots. So here's the current situation. We are expecting another sunspot to rise here in the northeast, as we've seen an M-class flare come from behind the northeastern limb. Likelihood of major flares is very, very high here, especially from this setting region. Sunspot 3174 and the accompanying sunspots. And of course also this region up here, which is not even in view yet, certainly doesn't have a name. And let's take a look at sunspots from SDO. This is the last 24 hours in SDO magnetogram. Here's SDO continuum. Most of those sunspot groups here largely remaining stable. Again, we are expecting an additional sunspot region behind this new sunspot group. So that new sunspot group, that'll be called 3178. I think there are more umbrae behind that. Again, we did see a significant flare come from that region. We will take a look at that here in just a moment. Here we've added 171 angstroms to make it a little bit more lively. And there's the full disk view in SDO continuum. Next, we'll talk about energetic particles. We haven't had any. Last I checked, no spikes in the ghost proton flux here for a couple of months. However, we have had some significant flares. So we just had a minor M-class flare, barely an M-class. Certainly looks like it was M-class. Let's switch to the 1 day. Let's switch to the 6-hour graph. That is as close as you can get to an M-class flare. It was a C9.5, I guess. So almost an M-class flare, not quite. Over the past 3 days, we've had 2 M-class flares. And let's take a look at those in 131 angstroms. So that's one of the best flare wavelengths. Also, 94 angstroms is a great flare wavelength. This is not X-rays, this is ultraviolet light, but it takes more images per minute than the other wavelengths, like 131 angstroms does. 94 and 131 are specifically designed to view solar flares. Well, maybe those flares just came from sunspot 3178. In any case, let's move on to orient ourselves, as we're always interested in what's going on overhead. We encourage you to look up and know what's going on in space. Space, it's not fake. If you think space is fake, go out at nighttime on a clear night and look at the stars. You may start to believe that space is real. Space is not fake. Anyway, that's what's going on over Lehigh Valley, Pennsylvania. That's in-the-sky.org's all sky chart. Make your own with your zip code or town. And here's your solar system forecast. We've got a first quarter here at the moment. We've got a gibbous waxing moon. So let's advance this 1 week. There's where things will be in a week. We'll be very close to the full moon. I think we're 8 days from the full moon in January. As we close out the year 2022, let's take a look at some coronagraphs. So here's yesterday's imagery. Things have been quite calm in terms of coronal mass ejections here. Not a lot going on. Some minor ones happening there. That is 96 frames from yesterday, December 29th. Here are today's frames. That's an additional 27 frames there. Some additional minor CME activity there. I don't think it's directed toward the Earth, but let's make sure. Stereo A's got some up-to-date information here. So let's take a look at this on the left. There is stereo A. And we're not seeing any earthly directed coronal mass ejections. Earth would be off to the right of the obscurement disk here from stereo A. It would be off in this direction. And we don't see any sort of CME activity off in that direction indeed. So here's the last 24 hours in composite. Quite calm here. Less CMEs than we've been seeing recently. There may actually be a stealthy one that is somewhat Earth-directed here. Certainly not showing up very well in stereo A. Let's take a brief look at that. Could be some missing data there or something. Yeah, I don't see anything earthly directed. What about you? Let us know in the comments what you think. There's a little additional zoom in. I think most of this plasma must have splashed back down toward the chromosphere. We did see a CME happening yesterday, but it looks like only a very tiny amount of plasma actually made it out of the solar corona. Next, we'll look at filaments. And I think this filament over here needs a name. Let's see. What's a good name for that filament? Let's bring up the latest image and share that to the Twitter page. So lots of filaments here on the Earth-facing side of the solar disk once again. Likelihood of coronal mass ejections remains kind of high. Likelihood of gaining followers on Twitter remains kind of low because content remains deboosted, aka shadow banned. Elon has not fixed any of that. I don't know why everybody's kissing his testes. Stop kissing Elon's testes. He hasn't fixed free speech at all. He's grabbed the mic, seized control of one of the most major media outlets in the world, aka Twitter, and everybody's thanking him for fixing censorship when indeed he hasn't done anything to reduce deboosting features. Yes, it is a good thing that he's exposed the malfeasance between Twitter and the government. No, it's not good that he hasn't done anything to reduce censorship on the pathetic, putrid, disgusting big tech platform. It's not fixed on Google, it's not fixed on Apple, it's not fixed on Twitter, and it's not fixed on Meta. All of these criminal organizations mislead their investors. So follow us over on Twitter. Okay, here's the last couple of hours in the GOES 16 SUVI, 304 angstroms wavelength. And I want to note one other thing about different solar data sources. So what's great about this one is that it has a wide field of view. It's great at showing CMEs as they happen, coronal mass ejections. We've got a crown prominence at the north and the south at the moment. We can expect some much more major ones as we spend another couple of years getting to solar maximum. Now I want you to look at the difference between the GOES 16 SUVI imagery, which is lower resolution and a wider field of view, and then the SDO imagery. So there's the SDO imagery at the same wavelength. Narrower field of view, higher resolution. Also, this is the last 24 hours as opposed to the last 2.5 hours. And before we get to our bonus feature segment, we will show the 171 angstroms wavelength by itself. It is the house favorite wavelength. And let's move to bonus features. So at the moment, satellite charging hazards are somewhat minor here. We're seeing some surface charging around the Central Pacific Ocean, Central America, and Mexico, and the Western Caribbean, rather. So a little bit of minor charging hazards there caused by low energy electrons on the surfaces of satellites. Shout out to Tamitha Skov. And let's move to the electron flux. So there's the GOES electron flux that's measured at the F layer of the ionosphere by the geosynchronous GOES 16 and GOES 17 satellites, and we're seeing a dip here. And that is typical of coronal hole high-speed streams. Thanks for leaving a comment, Bruce. Next, looking at relativistic electrons in the forecast model, and they are expecting a dip. I would tend to agree. I think the current coronal hole high-speed stream is going to be a bit short-lived. We'll see what happens. There's the one-year chart to put the relativistic electrons in context. And next we'll take a look at the F-flare and the vibrational frequency therein. Now the F-flare is the bridge between Earth and space. So that's located right about here at 300 kilometers of altitude. It's one slice. This is the vibrational frequency in megahertz. That's millions of vibrations per second. There's a lot of vibrating going on up there. And we've got massive anomalies to talk about once again. So it's not just the South Atlantic anomaly that's moved. It looks like the African anomaly has actually moved a bit north as well. So we're going to show that now because we're seeing this extended movement of the South Atlantic anomaly. It used to be in the South Atlantic. Then it was over to South America, like here. And now it is down here. So that is certainly an odd thing, as it has moved very rapidly over something like 1,500 miles here in a matter of maybe a week. You can see our previous space weather videos. We show this daily for just this reason. Very strange. A huge movement of Earth's ionosphere there. So the anomalygram will make this more evident because right here we've got this South African anomaly as well. So you see this variation right here where you see a huge striation there in the anomaly. This is an anomaly in megahertz from a 30-day median. So this helps to give us additional insight here, and right about where my pointer is, the South African anomaly has actually moved north, and the South American anomaly has moved way to the southwest. So that's certainly interesting. You can see the South African anomaly used to be way down here, and now it's several hundred miles north of there. So, I mean, there you go. Them's the facts, folks. The ionosphere anomalies have certainly moved. The weak points in the ionosphere are not where they were just about a month ago. Anyway, we'll let that play through one more time and bring up the latest image. This data is courtesy of Australian Government Bureau of Meteorology, by the way. There's the latest image. That's 11:45 Universal Time on the ionogram. And there's 11:45 Universal Time on the anomalygram. Quite a significant high-frequency anomaly here, just south of the South Pacific anomaly. I'm just going to start calling it the South Pacific anomaly since it's no longer in the Atlantic or over South America. Next, we'll show the total electron content forecast. This is the free electrons between your GPS satellite and your handset. There is the total electron content map. Let's press refresh just to make sure it's the latest. And here is your animation. So those are the most likely places to see GPS errors. They tend to be concentrated around the equator at noon, but during coronal hole high-speed wind streams, we often see these get very chaotic. And indeed, once again, coronal hole wind stream shows up. Free electrons are sort of all over the place. So huge GPS errors coming back to North America, the Northern Pacific. That's the Space Weather Prediction Center's total electron content map. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Next, looking at the latest the hell? Ew. It's showing me, why is it showing me ancient data here? 1228. Okay. Well, that isn't helpful. Let's head back to HelioViewer. I don't know what's going on with that. That's a new one. For some reason, the SDO site's showing us ancient data there. Anyway, we do have this new sunspot group rising. It is quite complex. It is beta gamma class at least. There is a magnetogram of that. I don't know why it's showing such ancient data, but let's just move on because it is time to cover meteorology. So once again, thanks for tuning into the Smash News Network, least busted name in news. And again, thanks for leaving comments, Bruce. We appreciate that. Today we're starting out our meteorology segment by showing some additional features of nullschool.net's fantastic Earth wind map. So here you're looking at ultraviolet light. So, of course, the dark side of the planet getting a very limited amount of ultraviolet light. And it's summertime. Summertime in the southern hemisphere. So there's the surface UV index. That is the erythemal dose rate. I have no idea what the units would be there. 13. It's just the UV index. Anyway, we'll switch to our regularly scheduled wind maps here. These are the surface winds of the eastern world. Here are the jet streams. Jet streams of the west are as shown. Surface winds of the west looking like this. Central world surface winds looking like this. And the jet streams of the Middle East, Europe, and Africa are as so. Don't be an as so and look at it as so. Next, please visit our links. Help the channel by clicking our links. You can find all kinds of links to our other content in the description below this video, as well as on the homepage at smashomash.com. Welcome to the DR Renaissance. We are still in the process of composing a paper plausibly explaining the solar sunspot cycles and solar polar field reversals. Not seeing anything to sort of eliminate my hypothesis as being plausible. If that paper passes peer review, it'll be the most important paper perhaps in 150 years in the natural sciences. One of the most important papers in human history. Next, getting back to meteorology. This is the 3.9 nanometer shortwave radiation map showing clouds and fog over the Americas. You can see the sun rising there over the South Atlantic. There's the North Atlantic. And welcome everybody to Croissant Earth. Earth. It's shaped like a croissant, while NASA would have you believe that it's shaped like an oblate spheroid. Next, looking at our weather.gov map, if your county's lit, click your county. We'll scroll down briefly to show you the key. There is the key. Again, if your county's lit, click your county. It's weather.gov. Looks like some good surf around the Hawaiian Islands. Winter surf season. It looks like it's just gone into full effect, as heavy snows inundate California, also heavy rains. So let's take a look at temperature anomaly first, as a bunch of warm weather is coming to the east part of the U.S. and some anomalously cold temperatures coming to California there. But check it out. Temperature anomaly in degrees Celsius for the next 72 hours based on the GFS model. We'll also show pressure and precipitation based on the same time period and model, the GFS. It's going to be a little bit moist over a lot of California in the coming days. Also some heavy snows coming to the Rockies and some strong storms around places like Baton Rouge at the moment. We'll get to it. First, the accumulated snow depth change in inches forecast based on the same model. Salt Lake City is going to get kaplastered with 2 feet of additional snow. And portions of California are expected to get over 3 feet of additional snow. Some areas pushing 4 feet of additional snow. Let's take a look at the Euro model. So that's the next 12 hours of new snow. There's the next 24 hours, and there is the next 3 days. I figure we showed the GPS forecast for 3 days. We might as well show the Euro forecast as well. And let's take a look at snow depth here just for a brief moment. And it's pretty snowy there west of the Mississippi, indeed. Indeed. Windy.com, all kinds of great features. And check out the extreme lightning here around East Texas and Louisiana especially. Yowzers. I think we've got some active lightning here around Baton Rouge as well. So let's take a look at that on our real-time lightning map, courtesy lightningmaps.org, powered by blitzachtung.org. So some heavy lightning there in the Gulf here at the moment. west of Nolens and northwest of Baton Rouge, also southwest of Baton Rouge, some active cells. It looks like they're closing in on you there, Baton Rouge. There is thunder rolling into the Atchafalaya National Wildlife Reserve. Heavy Gulf of Mexico lightning there. Probably because cold air is showing up and mixing with warm, moist air from the Gulf. Next, U.S. Doppler radar. There's the full 50-state view of ALSA, the allegedly United States of America. Former nation, now banana republic. The Constitution? Oh, who cares about your rights? Your rights are irrelevant. Rights? I don't need rights. I need safety and security. Anyway, there is your U.S. Doppler radar for the lower 48. Here is clouds and fog for the lower 48. As cold air from Canada mixes and creates a massive pressure gradient. So we've got a huge pressure gradient here. Check it out right here. We've got dry air mixing in with this moist air. That's what's really causing all that disturbance. There's a huge amount of moisture. And then there's a sandwiching process here as this air is getting plastered in between this high pressure region and this high pressure region. And that's causing an atmospheric waterfall, not to be confused with an atmospheric river that's occurring over around Oregon. Yes. Anyway, that's where we'll close things out. Here's your recap. U.S. Doppler radar showing vertical motion of water droplets in the air column. Here is shortwave radiation showing clouds and fog. It's too dark to use the visible, so we use this. And there is water vapor. That should give you the most insight if your Doppler is not giving you a clear picture. Hopefully we did here at the Smash News Network, least busted name in news. Citing facts. It's very controversial. We'll continue to do it into the year 2023. Thanks for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash. Signing off from the Smash News Network, least busted name in news. Facts stated in this video have been suppressed by big tech for your convenience. Opinions expressed in this video not necessarily the opinions of Smash News Network, the busted name in news.